Hello, welcome to the Data Structures and Algorithms program. This program is capable of doing sorting based on a desired attribute that user entered with using linked list. So let's start how the private part looks. In our class Özsoy, private part includes our struct, which group multiple pieces of related data into a single object. As you can see, I defined all my different attributes of student in here, and also defined next, which points to the next student record. And outside the struct, I defined my head pointer, which points to the first student node in a list. So let's start our public part. In public part, I defined my first function, which is swap nodes, which basically swaps two nodes. And it uses swap function, which is a built-in function from standard template library. And I use it. The swap function is used to exchange the values of corresponding data fields between two nodes. And one thing to mention about the parameters I defined, I use ampersand. Ampersand used for modifying the original pointers passed as an argument. Without doing it, the function doesn't work. So this is how the swap nodes function works. Let's start looking at our first sorting algorithm, which is bubble sort. Bubble sort works by repeatedly swapping the adjacent elements. If they are in wrong order, left to right, it will go left to right by swapping the adjacent element each time. After each sorting part will appear at the end like a bubble, and it will go iteratively like that until the whole is sorted. So let's start looking at the inside. I defined my current pointer, which indicates the current position, and my last sorted pointer, and initialized as a null pointer because at the start there is no sorted part. But after each iteration, last sorted is updated to the last node checked. And I initialize my bool value, which is swapped, and it is a flag value. I use as a condition in my while loop. We will see. In our do part, I initialize swapped as a false to decide while loop should continue or not. And current as a head, which is the head of the list, unsorted list, part of the list. And in our while loop, which is all the things happen, the current arrow next is not equal to last sorted. What this means is the loop iterates through the nodes before the last node, last sorted node. And it has a one conditional check. If swap the functions, if current one is smaller than the next one, it will check by the comparison function. It will return true or false. And if the condition is met, it will use swap nodes function, which I defined, and swap the values. Then it will assign true to swapped. And after this if statement, it will go to the next node until the last sorted node. It will go like that. After the while loop terminates, we will assign current to the last sorted to prevent any errors and to put them in the correct order. Then we will check the swapped true or not, then decide while loop should continue or not. The bubble sort will continue like that until the whole list is sorted. This is how the bubble sort works. Then we can look at the insertion sort. Insertion sort sorts the linked list by iteratively extracting each node from the original list. And not visually, but meaningfully, it divides the list as a sorted and unsorted part. We will see. And inserting it into the correct position in a new sorted list. We will see. And firstly, in our insertion sort function, I defined my sorted pointer and initialized it to the null pointer. Which is a pointer to the head of the new sorted list, initialized to null pointer because it is empty, and which is the left part actually. Sorted part is left. And I define my current pointer and initialize to the head, which points to the head of non-empty list, which is right part. We will assign right part to left part at each iteration. This is how the things happened inside the while loop. If current is not null, we will do the while loop. Student next will be equal, I declare student.next, equal to current.next node of the current. Then I will call the sorted insert method, and return value will be assigned to the sorted. Then current will be equal to next. Then it will go like that until the whole list is sorted. After the while loop terminates, after all nodes have been processed and the sorted list is fully constructed with using while loop in here, the head of the original list is updated to the point to the new sorted list, which is sorted. We will connect them actually in here. This line makes that. So let's look at the sorted insert, which all the things happened. Firstly, we have an if statement. If should check. If the sorted list is empty, or new node should come before the first node, means conf function return true, new node inserted to the head of the sorted list, which means left part. And we will see sorted equal to new node arrow next, which means add new one to the list. And we will return new node. But if this condition is not met, we will do the following. We will initialize our current as the sorted. Initialize to start. At the head of the sorted list, sorting starts again at the head of the sorted list. But we have while loop. If tail node doesn't reach the reached in here, it means that, and current node is bigger than the next one. Current node bigger than the next one. New node, current, and next one. We will go the next node until this condition not met. After this while loop terminates, we will assign current's next node to the new node arrow next. Connect this. What this line does is connect the new node to the next node. Then we will assign new node to the current arrow next, which means update the next pointer of the current to point to new node. Then we will return sorted list, which is left part. This is how the insertion sort works. Then sorted part will be returned and assigned to the sorted. Then this while will continue, and after this while terminates using this function, it will echo sorted to the head. This is how the insertion sort. Then next sorting algorithm, which is selection sort, which is a little different from the previous one. Selection sort works by finding smallest element of unsorted part. Again, we divide unsorted and sorted part, and adding it to the last part of the sorted part at each iteration until the unsorted part becomes empty, which means we sort the list. Let's start. Firstly, we initialize our current pointer to head, which marks the beginning of the unsorted part of the list. Then, I use an while loop. If current is not null, loop will continue until current becomes null pointer. So let's start how everything works. Firstly, I defined my min node pointer as a current. Current is a head, min node is a head. I take first node as a min node as a start. Then, one node after the current, I assign to the temp, 1 and 2. We will use it. In the while loop, if temp is not null, loop will start, and we have one conditional check. If temp node is smaller than the min node, this is the condition. Min node updated to the temp. Yes, we will do that. Then, when the loop terminates, min node points to the smallest node in the unsorted part of the list. And temp goes next one, smaller one, goes like this. Then, we will swap the current and min node, because we are not correcting current in here. We are just finding the min node. Then, we are correcting the list by swapping the current and min node. Then we are going to next one by current arrow next. The loop will continue until it reaches the tail. This is how the selection sort works. It works by taking current as a min node, then comparing it with the whole list and all that. So let's look at the quick sort. This is all different algorithms than we mentioned before. The quick sort. Firstly, quick sort is a divide and conquer algorithm, which divides the list as two parts, as left and right side of the pivot. We will need a declare a pivot for doing that. We will see. And this algorithm continues like that until the whole list becomes sorted. So let's start how it works. We have a base case in here. As you can see, if start is not null, and or start is equal to end, if it is our base case. and we will see how they work. I declare new head, which is a pointer to null pointer, and new end to the null pointer, and assign them into null. And I declare a pivot pointer, which takes the return value of partition function, which is the heart of the quicksort. It will rearrange the nodes such that the nodes less than the pivot becomes before the pivot and greater than pivot comes after. Partition function does that and assign that return value to pivot. After this now, we will see how the partition function works. If checks the if conditional check checks the pivot variable, is pivot equal to new head or not? If condition met, inside the if, we are initializing a temp pointer and to new head. Then we are using a while loop. If temp condition check temp arrow next is not equal to pivot, loop will continue until the node before the pivot. When it reach the pivot, loop will stop. It will go at going next node of the temp and until the pivot. Then next pointer of the next temp will be null pointer for disconnect the left sublist from the pivot. This is what I mean by concurrent, dividing and concurrent. We are disconnecting the list. Then new head equal to quicksort function's return value. It will recursively sort the left sublist until the pivot using quicksort function. It will go new head to tail and assign this return value to the new head, which is actually as a left sublist. We will see how this function works. And also we have get tail function, which will give us tail and assign it to temp. Then we will assign pivot to the temp arrow next. What this line does is reattaching the left sorted sublist to the pivot. This is inside the if function. Then outside if outside if, we have pivot arrow next equal to quicksort pivot arrow next, which is the and other side. It will recursively sort the right sublist using quicksort function. The pivot itself is already placed in the correct position. It means we sort the left part. It's time to sort the right part. We sort the left, time to right. It means that. Then, as a return, we return the new head after all of this sorted. So let's look at the partition function we used as the value of a pivot. So let's look at it. And we declare our pivot as an end. End node, which is the last node, is chosen as the pivot. We give it actually. And previous equal to null pointer, current equal to start, tail equal to pivot, initializing part. So let's start how it works. In the while loop, if this condition met, which means while the current is not equal to pivot, the loop will check the first if statement. If current smaller than the pivot, inside the if, it will check. If it is the first node smaller than the pivot, new head is set to the current. Then previous as current assigned to previous moved one. This means that. Then current will be assigned to the next node. Current is moved by one node. If this is not met, in else statement, else statements means node is greater than or equal to pivot. In the else statement's first part, prev arrow next is equal to current arrow next. If prev is not null. It is hard to show without any visual things to show, but if you think it as a graph, it comes visually because we are disconnecting the current from the main part of the list by updating the prev arrow next to the current arrow next. Then student temp pointer will be initialized to the current arrow next. It saves the next node by initializing the temp variable to the next of current because of disconnections we made. It's some kind of the error handling. If we don't do that, we will lose whole list. So we need to do that. Then current arrow next is equal to null pointer, disconnecting the current node. Then tail arrow next equal to current. Current is moved to the tail end node. Tail is updated to current, then current is advanced to the next node. This is how else statement works. It is something that visually have been think. It works like that. And while loop will continue until the current is equal to pivot. Then it will stop. So after the while loop terminates, we have this if statement. It sets the pivot as a head of the list. If new head has not been set yet, this means there should be only one element which is pivot, and it means the pivot is the smallest element. Then this is our if statement. This is all partition function. So the other one, our getDale function for finding the last node. While node is not null and node arrow next also not null, we will go the next one until the null pointer, then assign to the node to the next one. Then it will return the last node as the tail. It is how quicksort works. Text partition, assign as a pivot, then check these if statements, call itself again and again, recursively sort the left sublist onto the pivot. Using quicksort, left side sorted, call itself again, right side is sorted, then return the whole sorted list. It is quicksort. Then we have merge sort. This is a little bit different than the quicksort. Merge sort splits the list as left and right part. And it will go like that until each part contains only one element inside. Then it will rebuild the list by merging them back together in a sorted order. It is also divide and conquer algorithm, as you can see. So let's start. We have two if statement. It means if one of the lists is empty, return the other list. If left is empty, return right. If right is empty, return left. Because if one of the lists is empty, the merged result is just the remaining element of non-empty list. Then I declare a result pointer and this size to the null pointer. We will return. So first we start by comparing which one should come first by comparison function left right. If left smaller than the right, we assign result as a left. We left assigned to result. Then recursively merge the remaining part left to right. We will see how the merge function does that. If right is smaller than the left, which is as part, we choose right and assign it to result. Then again we recursively merge the remaining part right to left, opposite of that. Then assign it to result arrow next. After that we return the result, returns the result node, which now points to the head of the merged list. This is the sorted one. This is the sorted. This is what we want. So let's start. We have get middle function, which gives us the middle one. It works by the slow and fast algorithm. We assign slow pointer to node, then node arrow next node to the fast, and we use while loop. How the while loop give us the mid one is while loop will continue until the fast pointer reaches the end of the list. Because it goes two nodes at once, slow node goes one at a time, which is null pointer. When the fast node reaches the end, the slow node will only be on the middle. This is how while loop terminates, and this function works. and we will get the slow one as a return value because it is the middle one. Then we will use it in our merge function. So this is how this function works. So let's start our last sorting algorithm, which is heap sort. Heap sort is a comparison-based sorting technique based on a binary heap data structure, which is some kind of binary tree. It works in two main phases: building a heap and repeatedly extracting the largest or smallest element. We will see this algorithm inside this function. Firstly, we need to know size of our linked list. We initialized integer size to 0, then initialized temp pointer to head of the unsorted list. And then this while loop will give us the size. It uses while loop to count number of the nodes in the list, as you can see, until it goes to end, which is null. When it becomes null, the loop will terminate. We have the size. Then we have this array to make easier heap sort algorithm. I use double pointer to create an array where each element is a pointer to a student node. So I can use the nodes without changing the actual one, and using array, some kind of array. Then I initialize my temp to head. Then I use for loop for copying each element of linked list to the array, which I decorate in here. Standard for loop, it will get each node, copy it, then next one, until the for loop terminates. Then this is how everything works. We have max heap, how I build my max heap. Loop will start from the last non-leaf node, and it will be built until it reaches the peak by calling heapify function. We will see how the heapify function works in later. We have loop for sorting. It will go end to start, as you can see. We use swap nodes. Swap the root, which is the largest element, with the last unsorted element, which is index of I. Then I call heapify function with these values to reduce the size of the heap by 1 in each iteration, because I is changing by 1, and call heapify to restore the heap property. It means until each time we break it, then we restore it until the whole list is sorted. Then we will assign head of the array, first node, which is the first node, to the head. Then delete the array, which is just a copy of our linked list. Deleting it doesn't break anything. So let's start looking at how the heapify function works. It starts by initializing the largest integer largest to root. We assume root is the largest, because in the binary tree, root is the top one. In the algorithm, top one means largest. We assume that at the start. Then left index of the left side, right index of the right side in the binary tree. Then I use if statement. This part means that if the left child exists and count function returns true, set largest to left. Similar logic for the right side also. This part does that. Then other if statement. If largest value is not equal to the value of root, swap the values of largest and root. We are going to swap them, because we are assuming root is the largest. If it does not, we need to swap. Then we call heapify to keep heap property valid, which means restoring it. It will go again and again until there is no node to extract from heap data structure. This means whole list is sorted. This is how the heap sort algorithm works. Then these are the functions that I use in the main part. Let's look at them. Firstly, I use my Özsoy constructor and initialize my head to null pointer. Then there is an add student function which adds new student to a list, as you can see, getting values, assigning them. If no student on the list, head is a new student. If more than one student, it will add new student to the end of the list, and it goes like that. And display all student in the list, simple display function. Then our menu comes in. I get the choice. Then I get which one they want to sort it by, and that I get also that. Then I use comp if it equal 5 compare by gender on a good day, assign to comp. Then I use switch case to call the sorting algorithm desired by the comp as a parameter. But there's one different than the others. They are assigning the return to the head because the new head of the list is returned assigned to the head. Because this function returns a pointer to the new head of the list after sorting, as you can see in the quick sort. Where is the quick sort? Return new head. It is returning head of the new sorted list. So we need to assign this return to the actual head to see the result. This is that does that. Other ones is a standard. There's a default. Then there is our comparison functions for sorting based on the different attributes. They will all comparison function will return a Boolean value. Then we will take that Boolean value and all that. There's our main part, our objects, instances, our function call. Let's start the program. I will choose heap sort. Then I will sort by age. As you can see, it's sort by age, and it calls me to exit or continue the program. I want to exit. Program is exited. This is how our program works.